Okay, so the idea now is to talk about the convex hull. I want to talk about a very simple algorithm, or quite simple, or an algorithm that you can consider slow but maybe more simple to find the convex hull. So if we look on a bunch of points, let's make a bunch of points and look at their convex hull. So what is the convex hull of this bunch of points? The edges and the vertices and the edges between them that I can connect, that will enclose all the other points inside and quite create a convex area inside, where any arbitrary points in this side, the line between them will be in the convex hull. So this is the convex hull, and the idea is that I need to find those vertices that I need to connect to create this convex hull. So we will do the slow algorithm now, and let's look at the idea of the slow algorithm. To understand the algorithm, let's go a little bit back, and now let's look again at how we create this convex hull. Let's take any arbitrary 2 points, and let's try to understand if these 2 points, let's call one P and one Q, those 2 vertices are in the convex hull. The answer is of course no, but how can the computer, the algorithm, know that? Now what we are doing is taking an arbitrary point P, which let's call the set of points big P. Okay, this is the set of points. So let's make, maybe we'll take another let's call it P tag and Q tag, and P will be the set of points. So let's take another point, let's call it R, and PQ are also, P tag, Q tag are also part of the set of points, where P is the set of points. Okay, P is a point which is the set of points. Now if we look at, for example, this point, let's call it R. So what we ask now is whether this point is to the left or to the right of this line. If it's to the right, so everything is okay, but if the point is to the left, so it's not okay. My building is in this direction, in the clockwise direction, and in such case, if a point is to the left, so I know that this is not part of the convex hull. So I need to take this off and tell the computer, no, this is not part of the convex hull. Now I'll do this for each 2 points, and just when I get to 2 points, for example this one, P and Q, where for every point, other points, if I take it as R, for every other point, the R point will be to the right of this PQ, P tag, Q tag line. Only these points will be part of the convex hull. Again, if I continue now and do like this, of course this is not part of the convex hull, I should have done this, but let's assume I did this. So what will happen is that I will try to check all the other points. So for this R, it's okay. For this R, it's okay. For this R, okay. For this R, okay, it's to the left. But when I get to this one, no, this one is to the right. But if it's the right, so something is wrong with this new P tag, Q tag vertices. The problem is with the new Q, which is not part, because I know those two are part of the convex hull, but I now connected these two, and here I found R, which is into the left. Again, this is only because I'm going in the clockwise direction. Okay, but if I find this R, this tell me no, something is wrong with what you did. So please go back. Oh, I need this point. Please go back take off this edge and make again a try. Let's take this try. Now again, I look at this R, okay, maybe it's to the left, and this R, no, this is not right. This is not to the left. So this is not true. You can ask me here now, so how do I know if this point R is to the left of an edge? How the computer know? There are methods for doing this. There is a method using the determinant of the points, 3 points, P, Q, R, and see if the R is to the right of it, because the determinant takes the surface, what is the surface of the I don't know, parallelogram or something like this, and if it's negative, so it tells me that it is this direction. If it's positive, in this direction. Anyway, determinant can help me understand where they are. So only when I get to this one, I know that for any other R that I use for any other point in the remaining points, all of them will be to the right, because I'm going to right in the clockwise direction. So I say, oh, this is great, save this one and continue as you can, because this is very okay. And we continue again. I can do mistakes. I will find some R which is to the left. I understand this is not right, so I get this off and try another one until I go and get the convex hull. Okay, so this is the idea of this, let's call it slow convex hull algorithm. So if you look at that algorithm, it is called, the algorithm is called slow convex hull algorithm. Slow convex hull of P algorithm. Okay, so the input to this algorithm is a set of points which is called P, set of points in the plane. Okay, this is the input. Now the output is, of course, as I want, the convex hull. But how do I show this convex hull? So it will be using a list which I'll call L. It will contain the vertices of the convex hull of my set of points P, and it is directed again in the clockwise direction. Okay, now let's see how I do that. So the algorithm starts with defining an, let's say, edge groups, directed edge groups, let's call it E, which will start it as an empty set. It will contain the edges that are part of the convex hull. Edge group, edge set, that will contain the edges of the convex hull of P. Okay, now we continue, and now I will look for the all, let's say, for all now pairs, let's call them P and Q, that are part of the set P. Yes, all the order pairs, while P is not equal Q, we will start a variable called valid, which will assume is true in the start. And if now I'm going to look at this pair and look at the edge, and if now I find any R, any other vertices, where any other vertex which are called R, any other vertex which are called R, if it is to the left of this pair, so I'll say this pair is not part of the convex hull. It is not valid, and I will change the value of the valid to false. So how do I do that one? So I need to go, and for all r part of P, namely I take all the points which are not equal to the pair of points I'm looking at now, to P and Q, not equal. What I do, I just check, for example with determinant, do if L, what L? If R, check if R to the left of the line between these two vertices, P, Q, if so, I'll just change the valid to false, then valid equals false, and understand that this PQ is not part of the convex hull. But if I check all the vertices, for all the vertices, I do this in a loop. So if I end this loop and valid is still true, if I end this loop, I checked all the vertices and still valid is true. So if outside the for, when I end checking all the points, if valid is still true, then I know that I can add those 2 points and the edge of them to the convex hull. So add the directed edge, let's call it PQ, to the set of edges that are part of the convex hull, add it to E. Now, from this set of edges, which contains all the edges that are part of the convex hull, I will construct the list that I will return the list of vertices that build the convex hull. So from this set of edges, E, which contains the edges that are part of the convex hull, we will construct this list L of vertices of the convex hull of P. Now don't forget that I'm sorting it in clockwise direction. Okay? And this way I did exactly what I showed you in the example. I look just in any pair, I checked every other vertex in the set to look if there is any vertex which tells me that it is to the left, and if so, I just tell the edge is not part of the convex hull. So I tried another one like this, and I check every other vertex. If all the other vertices are not part of PQ, all of them are not to the left, then I said this edge, great, take it to E. This edge, great, take it to E. This edge, not good, get out of it. Get out of here, get rid of it. And I collect all of them, all those edges. And those and this one too. And from all of these edges, I build the list which will contain the vertices which are part of the convex hull ordered in the clockwise direction. This is the slow algorithm to build the convex hull of a set of points P. So this is the slow convex hull algorithm. Thank you very much. If there are any mistakes or correction, please tell me. And that's it.